Welcome to Manas Studies. Let's start the next topic, that is functions. Now, the first topic of this chapter will be graphs. Let's say we have to trace the graph for y equals x square. Now, just a moment. Okay, let's begin. If I have to trace the graph which is y equals to x square, let's take the coordinate axis. This will be x axis, this is the y axis. If x is equal to 1, then y is also equal to 1. If x is equal to 2, then y will be 4. If x is equal to 3, then y will become 9. So the graph will look somewhat like this. And if I put x as minus 1, as minus 2, or minus 3, I am going to get symmetric values, so the figure would look symmetric. This is known as an upward parabola, which we are going to focus in the later part of these chapters. It was just the introduction of how simply the graphs are traced to give you an idea how the graph looks like if it is represented in the form of equation and how it looks like if it is represented graphically. So now let's move forward to another technical term which we had covered in the previous chapter, domain. Let's revise what is domain. It's the set of all acceptable values of variable x. In this case, I can put any value of x. If I put x is equal to 5, it's going to meet the graph at some point and it will be x is 5, y will be 25. If I put any other value, let's say 5.1, then y will be equal to 5.1 squared. Similarly, any value of x can be input into this expression. So the domain in this case, so domain of this expression can be written as the set of all real numbers. Now let's cover range. Range is the set of obtained values of variable y. In this case, let's look at the values of y. The value of y will begin from 0 and will go until infinity. Y cannot attain any value which is negative because it is equal to x squared. So the range of this expression will be written as all the values starting from 0 going till infinity. So the interval will be 0 to infinity, and as we had covered in the previous chapter, 0 is included. So we are going to draw a rectangular bracket, but because we cannot reach infinity, therefore we are going to put an open brace. So 0 is included, infinity is not included. Now, what is the root? You must have studied it in quadratic equation when they used to write ax square plus bx plus c equals to 0. And by Sridharacharya method, we used to write x is equal to minus b plus minus root of b square minus 4ac upon 2a. We used to get two values of x. They could either be real and distinct or equal and real or imaginary, but the two values were known as the roots of the equation. It is that value of x which when input in this equation gives the result as 0. Now let's look at maximum and minimum values. If I have a graph which looks like this, let's say it is something like this, extending on the x-axis from 1 to let's say 5, and on the y-axis they are going from, I'll take the numbers as 2 and 3. Now the maximum value this graph can attain, let's say it is over here. So the maximum value attained by this graph will be 3. The maximum value of the graph is attained equals 3. But if instead of this some other graph were drawn which looked like this, and the value 3 at 5 was not obtained, a filled circle denotes that the value is included in the graph, but an open circle denotes that the graph does not include that value. So the maximum value in this case will be written as does not exist, because it is impossible to write the number which is just smaller than 3. Some people might say that the number is 2.9, then someone else might say that the number is 2.99. Someone may say that the number becomes 2.999. Now, this is not wise to say that 2.9 would be just smaller than the number 3. Therefore, we are going to say that if you want a number which is just less than 3, it is not possible, and we are going to say that it is does not exist. Now we are going to say the same thing for the minimum value as well. If I say that the graph extends from 1 to 5 and 2 to 3, if this is included, anything may happen over here. I'm talking about the minimum value. So the minimum value in this case will be written as 2. But if I'm talking about a different graph, and in this graph the number extends from 1 to 5, from 2 to 3, 2 is not included and it's going to here. Now the minimum value does not exist. It does not exist because I cannot attain a number which is closest to 0 but not 0. That is a number which is just greater than 2. Some might say that it is 2.1. No, because 2.01 is closer to 2 and greater than it. Someone might say it is 2.0001. It is also closer to 2 and greater than it. Because we cannot identify any number that is just greater than 2. Therefore, we say the minimum value does not exist. Now let's look at the next slide, which is yep, asymptote. Now asymptote is a straight line which if exists towards which graph of the function approaches indefinitely. Now let's say the graph looks something like this. This is my line and the graph is approaching like this. The graph is not cutting that line. It is not intersecting that line, but it is approaching towards that line indefinitely. Therefore, it is said that this line y equals m is an asymptote to the curve. Now let's look at boundedness. A function is called bounded if a number m exists such that the function is not going to cross that value. Then it is known as bounded. Let's look at an example to understand it better. If the graph looks like this and these are a comma b, because this graph is not going to cross the line y equals to b, we can say that this graph is upward bounded at y equals to b because it is not going to cross it. And if this point is c and the graph is not going below this, then we can say that the graph is bounded at y equals to c as well. This is upper bounded and this is lower bounded. Let's look at a periodic function. Periodic functions are those whose graphs repeat themselves. For instance, if the graph looks like this, then it's a periodic function. If the graph looks like this, it's still a periodic function because the graph is repeating itself after a set interval. We can also draw it like this. Since the interval is repeating itself again and again, therefore we call it a periodic graph. Now we are going to focus at some elementary graphs. Now what is a constant function? A constant function can be written as such as y equals a. So now this will be drawn like this. Since the value of y is always a, it can even be written as x equals b. If I draw a graph on which the value of x always remains b, these two are known as constant functions. Now let's look at linear function. In case of a linear function, it is similar to the concept you have studied in class 10. Ax plus by is equal to c. We can draw a straight line and it will be denoted by the standard formula ax plus by equals c. This is known as a linear function. Now there are some advanced functions. We are going to cover them and it's better to remember them so that you can use them directly. If the expression looks like y equals to x to the power n, where n is an even multiple of m, so it will either be x square or x to the power 4. As you may remember, the first graph which we drew was of y equals x square and the graph looked something like this. So all the even powers of x, be it x to the power 4, x to the power 6, x to the power 8, all those graphs would look like this. If instead of the even number there is an odd number such as x cube, x to the power 5, x to the power 7, then the graph would look like this. They can be easily traced and it's better to remember them so as to use them directly in the question. If the graph is of y equals root x, that means the graph is going to look like this. Since I cannot input any value that is negative of x, so in this case as we see x cannot be a negative value, root के अंदर negative आ नहीं सकता है और आउटपुट भी नेगेटिव हो नहीं सकता है, इसलिए द ग्राफ विल बी लिमिटेड टू द फर्स्ट क्वाड्रेंट. अगर यहाँ देखें अब ये हो जाएगा क्यूब रूट ऑफ एक्स और द पावर ऑफ एक्स बिकम्स 1/5. देन द ग्राफ वुड लुक लाइक दिस, क्योंकि इसके अंदर अब मैं नेगेटिव वैल्यू डाल सकता हूँ. एज यू नो क्यूब रूट ऑफ -8 is -2. It's better to remember these graphs and use them when the question asks to.